Hello, everyone. Welcome to another Techbytes event. For those of you watching for the first time, Spotify Techbytes is our tech speaker series where we invite both internal and external speakers to join us for a deep dive into a range of tech-related topics. Our goal is to increase knowledge sharing in and out of Spotify. Today, we're doing a fireside chat with some special guests who will be introduced in just a moment. We hope you enjoy it. So with that, I'm going to hand it off to Karen Segal, who will be moderating this event. Thanks.
Thanks, Kai. I'm super excited to welcome everyone today to the Type System Fireside Chat with our special guests, Jordan, Ben, and John. I'm really fortunate to have this opportunity to bring together my friends from college, as well as my coworkers, due to all of our shared interest and involvement working on type systems. Jordan and I usually have a regular cadence for catching up back in New York City due to the proximity of our offices. And since hearing about the talk that he gave at React Native EU on enforcing consistent UI using type systems back in September, I've been really interested in bringing him into Spotify. And since then, a few months back found out that Ben is actually working on developer tooling on specifically to TypeScript and JavaScript over at Microsoft. And combined with that, found it particularly interesting given that John was part of the efforts to introduce TypeScript to all of Spotify, as well as my own experience on my team migrating an internal React component library to TypeScript. So that brings us to today on this opportunity to bring us all together to discuss more about type systems. And I also found it really interesting that Jordan and Ben collaborate a lot, even though they seemingly work on competing systems. So with that, I want to more formally introduce our incredible panelists. So Jordan Brown works at Facebook on the Flow type system. His focuses are on the Flow React model and Flow object model. Right now, that means preparing Flow for the create element RFC that the React team is working on and designing a Flow equivalent for map types. When Jordan adds new syntactic features, he also contributes to Babel, Prettier, and JS CodeShift. Thanks, Jordan, for being here.
Thanks, Karen.
Ben Litchman works at Microsoft on tools for TypeScript and JavaScript developers. Primarily, he works on the JavaScript and TypeScript experience in Visual Studio, but also regularly contributes to the JavaScript TypeScript experience in Visual Studio Code, the TypeScript language itself, and other tools such as ESLint and Definitely Typed. Thanks, Ben, for signing on today.
Mute button, happy to be here.
All good. I'm sure we'll all encounter that a little bit. And finally, John Rodriguez works primarily on the user-facing components of a multi-channel messaging platform at Spotify. He helps lead the research and adoption of TypeScript across all of Spotify, and I'd highly recommend watching the Techbytes video from the talk he gave on our Techbytes YouTube channel. So thank you, John, for joining today as well. So just to, I guess, start us all off, it would be really interesting to know how you all first became passionate working with type systems.
So for me, I started getting interested in languages so I was a sophomore internship in high school, or in college, sorry. And I was working on a security team at Facebook, working on different ways to log into Facebook. And there was like one big configuration file that had them all laid out. And there were a couple of invariants that needed to be preserved in that configuration file. So I was trying to figure out how to like parse this like sort of Python-y looking code and enforce certain properties. And then someone was like, oh, like you should not be using like regular expressions for this. You should use a real parser and like do an AST analysis based on that. I was like, oh, what's an AST? And then from there, it was just like opened a whole new world for me. And so I was lucky enough to be very good friends with Ben in college, and he was already passionate about type systems. And so he kind of like took that like little spark and he was like, well, why don't you take this class? Why don't you do research with this professor? I think you might find it really interesting. And so, I mean, I'm here because Ben brought me here. So thank you, Ben.
Cool. And I guess I can sort of follow up on that question too. So I actually started my career as a C# developer. So for those of you who may not know, it's kind of like Java and very similar in its verbosity. So when I switched over to front end, I found the sort of dynamic nature of JavaScript a little more freeing. But over time, as I worked on larger projects, I found that it was kind of harder to keep things correct and, easy to introduce errors. Around that time, I discovered Elm, and that sort of rekindled my interest in type systems. I mean, up to that point, my main experience with types had been the C# and Java style type systems. That didn't really give you that much of a benefit. But then when I started using Elm, I saw that, you could encapsulate a lot of your program's logic in the type system as opposed to a runtime, and the type system gave you super helpful errors. And to me, even now, that's the gold standard is the Elm developer experience. So from there, I just started becoming a little more interested in how I can replicate that in my day-to-day, which led me to Flow, which I've used at a past company, and TypeScript, which we use at Spotify.
I guess you can, if there's anything to this question that you want to address, you can also address it when we discuss the next question. Okay. So I'm also curious where you'd all like to see type JavaScript get to in the future where it isn't yet today. Maybe John, or Jordan, looks like you unmuted.
I was going to say,
Jordan,
I want to hear John's answer first.
Sure. Okay, I can take this.
That would probably inform my answer, or it should inform my answer.
Sure. So like I mentioned before, I think Elm has the gold standard for error messages, but I find its way of interoperating with third-party JS to be a little clunky with ports and everything. So I think, to me, something closer to ReasonML, where it's very strictly typed, but the type inference is super top-notch, so you don't need to be very verbose about declaring things. Something that supports maybe common JavaScript idioms, and most importantly, something that has a module system that resembles typical JavaScript usage. One of the pain points with ReasonML, I find, is the OCaml module system, which is sort of, I guess, orthogonal to the way that JavaScript imports typically work, in that, every file is its own module, and it sort of requires you to, I guess, adopt a different way of code organization and a way of working. So something that sort of preserves idiomatic JavaScript usage while sort of getting closer to the ReasonML and Elm levels of helpfulness and correctness would be maybe my wish list.
So for me, the biggest things are, well, specifically on Flow, plugging up a bunch of the soundness holes that we've created in order to support common JavaScript idioms, but not just plugging them up and not having an alternative. Ideally, I'd also like to see typed built-in libraries to Flow or TypeScript, where there's these common idioms in JavaScript before they're hard to type. So instead, we give you this library function that we can either make a built-in type for, so we can model it really well, or just make it easier for us to model it because it uses types that already exist. And so with that soundness, we would also get more completeness because we provide these new library functions, so people could write more code that they would want to, and by construction, we'd be able to type check it. And in general, just seeing more type-friendly language features being added into JavaScript would also be really nice, because if it's easier to model on our side, that makes it faster for us to support.
Sound better now? Okay, let's hope it stays good. For me, just to take a slightly different tack on this, I think my North Star is really developer ergonomics, right? Where I would want to see typed JavaScript go is whatever it takes to have more of it. I was talking with friends who are C++ devs and C# devs who were saying, I would never trust a web server that was running a Node application because, you know, they might have used TypeScript, they might have used Flow, but I don't know that. And if they're using vanilla JS, I don't trust it versus, you know, an ASP.NET server or something. And so as we see, you know, better tooling coming out, so it's more and more common for people to use these tools, I think that will help JavaScript grow and, you know, just provide more trust for the system. And that's really my goal.
Cool. Did you want to speak at all to how you first became passionate about types? I know you got cut off a little earlier.
Yeah, so I don't know where you lost me at that point, but basically the structure of all of it was really the most exciting part to me, to be able to provide structure to language. And then, you know, in college, I was really interested in just, you know, making tools that could make code safer for people. And I've really tried to continue that forward from research land into industry land, if that makes sense.
Yeah, I was going to say, I think you and Jordan had some interesting experience in college working a little bit more with researching type systems. I don't know if both of you wanted to speak at all to that, because I think that's some interesting context that other attendees might find interesting.
Yeah, definitely. To not go too far down the research rabbit hole, my focus in my research was, you know, what do we use type systems for? When we're talking about TypeScript, we're talking about Flow. We're saying, before I ever run my code, I want to know that this is not going to crash, that these, you know, data types are equal, you know, whatever, just as much structure as you can get ahead of time. My research was in, what if we can add another layer on top of that? What if we can say, not only is it not going to crash because, you know, you made some logical mistake or something, but really at compile time, you can get a runtime bound on what your program is going to do, or you can get a bound on how much heap space your program is going to take up. And so for me, that was a very natural extension of, you know, what we talk about when we talk about type systems is just providing more and more guardrails for programmers so they can focus on doing what really matters.
Great. I think, oh, Jordan, feel free to.
Oh, so my work was also very similar to Ben's in that it was extending the normal guarantees you usually get from a type system. My work was specifically applying it to security issues, well, privacy issues mainly, and trying to see how we can get privacy by construction from our type system. And it was a lot of fun. It's cool to think about those kinds of problems.
Cool, yeah. I always found it really interesting hearing about the research you were doing. So it's cool bringing it all together to what you're doing in industry now. And I think what Ben was just getting at could be a good segue to something else I was curious to know in terms of how your work now, you think about developers that are working on doing migrations to type systems and at scale, how you think about that in your own teams.
Jordan, you first.
So when I think about migrations, it's usually migrations to new versions of Flow from existing code bases. Migrating from a plain JavaScript code base to Flow has it's like a lot of work, but there's a good system in place for it. But it's hard once you started relying on Flow already, and then we do something where last half I overhauled our object spreading model, and that caused several thousand errors internally. It was over 100,000 errors internally, and I spent most of the half trying to drive that number down. So I spend most of my time working, trying to figure out how to minimize the effect of the errors that I create and trying to make it as precise as possible.
Yeah, I mean, for us, it's, I think migration is a major focus for us, and making sure that that's as pain-free as possible. For example, we've been investing a lot recently in allowing you to use a JavaScript file with JS doc annotations, with TypeScript types in the JS doc annotations, and providing editor support so that that's interpreted and used in your editor experience. You know, you're getting IntelliSense, which is the Microsoft editor specific term, but you know, you're getting hints or completions, which are based on those JS-doc annotations. And really, we just see this model of, okay, you can start with a plain JavaScript code base, and you can sneakily add in JS-doc annotations here and there. They don't have to all line up. We'll just help you where we can and stay back where we can't. And as that goes, it becomes easier and easier to transfer that into real TypeScript annotations where needed. Another example being the linting work that Karen mentioned earlier, right? From the TypeScript world, we have TS-lint. And in the plain JavaScript world, you had ESLint. And this was a real problem with people with, you know, really mature ESLint usage who wanted to switch to TypeScript. They would have to drop all of that. So we invested a lot recently in making sure that TypeScript was supported in ESLint's ecosystem, so that wasn't a barrier for people to migrate. So that's just a couple examples of how we're constantly thinking about that migration story.
And then I can add to that a little bit more from, I guess, our perspective here. One of the things that we did that was, in my opinion, pretty helpful is we sort of sat down and we sort of came up with a migration guide, and we came up with some skeletons. So like, people with existing JavaScript applications and libraries, you know, would have a sort of like ready-made path to migrate to TypeScript. You know, we encouraged incremental adoption, which I think is made super easy by the various escape hatches, you know, like any, and, you know, the various tsconfig options that allow you to sort of customize that to the state of your code base. So we just encouraged people to kind of like incrementally migrate, and we made sure that we provided a lot of guidance and things like that. We had a strong foundation as we, you know, kind of approached that. You know, for us, it was important that we had one path towards migrating and not just kind of like every team is on their own. One thing we found, I guess, at a previous company where I had been using Flow is, you know, we used code mods sometimes to resolve a lot of the errors and things that came up when upgrading from one version of Flow to another. So we haven't, at least my team has not, you know, tried using that with TypeScript yet, but that might be another possible solution.
I'm curious, what didn't go well?
So, well, one of the things we found at first was that the errors were a little bit opaque. So sometimes, you know, like if you have an object type and certain properties don't match up, it's often difficult to find, or it was, I will say it's gotten better. It was often difficult to, you know, determine what the real root cause of the error was. So like we definitely spent a little bit of time kind of coming to grips with those errors and how to interpret them. But that was more like a one-time cost. Like once we had, you know, like learned how to parse those messages, I think it was just like we knew what to fix. And as I said, the error messages have improved significantly since that time. So I think it's a bit easier now.
There was just some interesting touching on, you know, how we go about migrating these things. And I know, Jordan, you've spoken about how your team views, say, linting as warning as you're migrating. Would you like to speak more to that?
Sure, yeah, we're kind of going through a big change into how we think about linting right now. Previously, we viewed Flow's job as finding only what would be a runtime error in JavaScript, and lints as being extra strictness that you can opt into if you want, but that aren't necessarily catching runtime errors. Like a good example of this is if you add, I think, like number and undefined, it produces a nan. So that's not a runtime error, it's still a number, but you probably still want to call those things out. But we found that people actually want us to be more opinionated about these kinds of pitfalls. And so I think right now we're going through this big restructure where we're thinking about all of our lint rules and deciding whether or not those should just be part of Flow, and if we should have like an internal linting system at all, or just let other people write lints for Flow code and like commit to one standard language with no opt-in extra strictness.
Cool. Thanks for sharing that. I guess there's actually some questions coming into the Q&A box or chat feature. I don't know. This one's interesting to that point about maybe what language features would you like to add to JavaScript that could improve the experience of using Flow and TypeScript?
Ooh, you know what? Maybe Jordan and Ben, you guys have answers to this too, but for me, like one big feature would be real, like actual variant types, you know, or I guess like case classes or discriminated union types, whatever the language specific terminology is. Right now in JavaScript, we have to sort of simulate that using object literals with a discriminant key property. So it'd be really nice to have that supported at the language level, because I would imagine that would make a lot of typed code more concise and clean and correct. Maybe Jordan or Ben, if you guys have any other.
Yeah, I'm trying to think here. I think I don't get so much involved with the JavaScript design process. And actually, as Karen mentioned, a lot of my focus is on Visual Studio. So I'm writing about half JavaScript and half half TypeScript and half C#. And so I'm trying to think like, oh, what is there in C# that I would really want in TypeScript? But nothing's really coming to mind at the moment.
So internally, we found a similar need to what you were describing, John, where, you know, we have a lot of these discriminated unions and they're hard to work with. It's also sometimes hard to determine statically that it is one of those like special union types and should have this special behavior. So the first step that we took towards solving this problem so far is by introducing enums into the Flow language. This is our first runtime feature. I think it's something that TypeScript has. And so the problem it solves is we have some of these like literally 70,000 member string union or string literal unions, and they're extremely difficult to work with. And sometimes they could lose their like optimized internal representation and cause extremely slow type checking. So the way that we think about these kinds of language features is how can we help people who are already using these patterns in sort of an ad hoc way, do it in a way that's performant by design. And those discriminated unions and just regular unions are the two big cases where that's come up so far.
Awesome, thanks. This might be an interesting segue to talk a bit about how Jordan, you and Ben collaborate a bit on problems you encounter at work. I think that's something I was curious to know more about.
Yeah, certainly. So for us, just to be really concrete about it, we recently had an issue where, and you may have experienced this as TypeScript developers in the audience, where the behavior for a long time has been, if you're importing from a module and all that you're importing from that module is type stuff. So if you're importing a class and you use it in a type position, or if you're importing an interface name, then in your runtime JavaScript, we're going to take out that import. We said that's not going to affect your output. It's not a problem. And what we heard from Angular users in particular was, no, we need that because we'll need to import a class and we may just use it as a type annotation, but really by importing that, it's being registered for the dependency system, and it's actually a stateful import. Please stop erasing our imports. And so we said, okay, let's make this more explicit. We need something that says import type, which is I'm importing from this module these type names, and you can erase it, or import whatever, don't erase it. And Flow had this. And so we actually reached out to Jordan as a team and said, hey, like what went well, what didn't, what do you wish you had done differently? And for things like that, we opened the communication channel and really worked together to try to improve on what's been done before.
There's also the less formal collaboration between me and Ben that goes on, where I just will text him a snippet and be like, how messed up is this? and then we'll just be like, JavaScript, man. That's how it works.
That's great. I love that. Might be an interesting segue to another question that came from the audience about how much you keep an eye on or take inspiration from what's happening in other languages. And are there concepts that you see trickling down from there to the languages that you're working on?
Yeah, I can take that first. So, I mean, certainly at Microsoft, you know, we're fortunate to be in a part of the company which is working on a lot of different languages. Whether it's, you know, we'll regularly meet with the folks who design the C# language. We can reach out to the F# folks, but also, and I noticed this in the chat, like, you know, Python as well. And so there's a lot of, at Microsoft, we're very lucky to have a lot of cross-language collaboration from the designer perspective. And so, yes, certainly I've seen little things trickle down. For example, recently, JavaScript itself has added, or been working on adding, I'm going to get the term wrong, but it's basically a question equals operator, or a question equals operator, where if something is null or undefined, you assign it, otherwise do something else. That's something that I think existed already in C# or will exist, and so there's a lot of cross-language communication there.
Some of these like more sophisticated language features also are somewhat required by some popular JavaScript libraries. Like React, I think, requires that your render function be pure, and Flow doesn't have like any effect tracking type of system, but some more sophisticated languages do. So it's almost pragmatic for us sometimes to consider how we could start to support these more advanced features so that we can support like most widely used libraries that we use in Facebook internally.
Cool, thanks. I guess you also sort of were starting to touch on this, Ben, about the opaqueness of errors as say TypeScript users are developing. Curious to know if either all of you have opinions on what advancements you want to see from compiler output.
Yeah, I mean, I don't have specific comments other than like, this is a pain point for our users, right? You know, as John said, right? Our errors are sometimes really hard to read. I've seen memes about the giant like error triangles that you get where it nests down and nobody knows what's going on because you have to scroll. Error UX is important to us. It's up there with, you know, the migration stories that I mentioned earlier. And so I can't really speak to like what specific improvements we have done in recent releases or we're looking to do, other than that we're constantly focused on it.
Yeah, I would say, you know, from my perspective too, like as I mentioned before, the TypeScript error story has gotten a lot better. When I used to use Flow, I know it's been a couple years since I've used Flow, but the I guess the upgrades to the error reporting have gotten a lot better. Like I remember some of the first versions were just kind of like all white text, and then it got to the point where it was color coded and it would show nicely formatted code and like a caret where your error was, you know. So I'd like to see more of that, just kind of like pinpointing exactly where the error is and just maybe being more verbose in explanation, but not necessarily in like a technical way, maybe more of like a human readable or friendly format. So I think definitely the way that the error message reporting is going is the right direction, but maybe, you know, like I would just like to keep seeing more of that.
Cool. I guess something that could be interesting for the audience as we talking about error messages that we're familiar with the developer experience using these languages. Be interesting to know what the main challenges you have working on the TypeScript Flow developer experience. So from the flip side, what your challenges are.
Want to take this one, Jordan?
You go first.
Yeah, I mean, for us, it's, I think, performance and reliability is one of the one things that we've been looking at recently. You know, as you may be aware, as TypeScript developers, you know, we rely a lot on definitely typed to provide API surfaces for common libraries. And one of the great things about definitely typed is that it's, you know, community driven. And that's one of the really difficult things about it as well. We've been working on making sure that contributors to definitely typed have some sense of the performance impact of their changes, because, you know, you can have this library that does really cool things. It makes you feel like you're writing Haskell. It's doing crazy things with our type system. And then your build time like triples. And you may not realize that or be able to, as a user, be able to trace that down. And so I think we're taking a little bit more of a stewardship role in this, in making sure we're not, you know, unnecessarily driving up build times on our end of things, but we're also helping the definitely typed community, you know, stay performant as well, if that makes sense.
I think I saw a article today about how your work in that area, I think it's coming out in 3.9, which may not be out yet, but I saw it was like reporting
yesterday
reduced build times, yeah, by like 40%, which is awesome. Yeah, so congrats on that. That's a huge win. We've had to deal with very similar problems internally also, where people have these like 100-line long like conditional types, the equivalent of conditional types in Flow, and you know, they'll either post a support question being like, hey, I don't know why this error happens. And then we go and look at the type of the expression that they're using, and would like take us a whole year to understand what it is. And on top of that, the file takes like 40 seconds to check. So we definitely have that same problem. There's someone on the team last half who was very focused on like hunting these down and either replacing them with types that made sense, or finding if the type really made sense and it was just Flow's fault, figuring out like what the pattern was and optimizing for it in our type checking algorithm. So we've had to do the exact same thing.
Yeah, I mean, I think that's one of the really interesting points of, I guess, distinction between the work that we do and the work that you do, where, you know, for us, locally, right, you know, TypeScript itself is written in TypeScript. So, you know, our number one example is, you know, what does it feel like to work on TypeScript while we're working on TypeScript, right? But, you know, we don't have the same large code base focus as built in as you do. And so for us, you know, as you pointed out, 3.9, great performance wins. That's really exciting. Here we go. Try it. Give us feedback. But you know, that's something we're coming to now as a real area of focus. With Flow, you know, the major consumer of Flow is Facebook's code base at a wild scale that I can't even imagine. And so performance has to be your bread and butter, and it has to be like one of, you know, what you're really focusing in on. And so whereas we have this sort of wide scale, you have this, you know, core code base that it's really your job to shepherd and make sure the experience for that code base is really strong.
Yeah, and you could see that pattern in basically every answer we gave, where all the things that I focus on are correctness and then rolling it out to one giant code base. Performance for this one giant code base because it's so massive. And so like as a result, the Flow team has sacrificed on the developer experience for a long time, and TypeScript is like light years ahead of us right now. And we're like finally at the point now where our performance is in a good enough place that we can tell people internally, we're not going to focus so much on performance right now, because the biggest pain points we're getting from people are that our autocomplete only fires like 40% of the time, that there's no auto imports, stuff like that. So it's funny that we're like coming to this point now where, you know, like you guys heavily optimize for developer experience and now have these performance issues, and we heavily optimize for performance, and now our developer experience is severely lacking, and we're basically like about to cross paths.
Great, super interesting. Is there anything, any improvements kind of on the flip side where you would like to see from the maintainer workflow? Like the maintainers of the TypeScript or Flow, maybe from the open source side?
You know, I feel like I'm hitting all these like recently invested in, but it's true. So like I keep mentioning Definitely Typed. It's the largest repo on GitHub as far as I know. And the way that we run Definitely Typed is everybody on the team takes a week and merges, you know, reviews 300 PRs, right? And so as TypeScript's usage grows, you know, that burden grows more and more. And so we've been interested in, you know, working on automation tools to really help with that. You know, we had some before, and we're working on the next generation of that to make sure that our experience maintaining Definitely Typed is not all consuming, but also those contributing to Definitely Typed have a little bit more of an automated workflow, that they don't have to wait for me to show up and tell them that I don't like their tabs instead of their spaces. And, you know, we can help them a little more proactively with that.
One thing I've found actually, maybe there was a way to do this before, but I know with 3.9, you guys introduced the annotation to ignore the errors. The TS ignore, I forgot, what is it called again?
Yeah, so I think in
error?
3.9 there's TS expect error.
That's the one.
It was just TS ignore.
Because one thing that I found when writing types for Flow was that since Flow had that sort of annotation, like ignore error, it made it easy to almost like write unit tests for your types in a certain way. And so like as a contributor towards Definitely Typed, I think having that functionality now will make it better to, you know, sort of have more confidence in more complex type expressions, because now you can sort of like test the failure cases as well as the happy paths.
Definitely, yeah.
Jordan, I don't know, I couldn't tell if you were about to say something.
I could talk very briefly about this. So Flow and React are heavily intertwined right now. Like we don't have React on the Flow equivalent of Definitely Typed. We actually only very recently moved React DOM onto Flow type, which is our equivalent. And the React team has been asking for us to do this because they want to own their own library definitions, because the vast majority of changes coming out of React right now are typing for hooks or new hooks that they're adding. And those are hooks are my favorite thing to ever happen to React, because it took something that was like a very complex library and boiled it down to like very easy to type functions. And so now that they're there, what we're trying to do is try to accommodate them a little bit more by saying, here's like the small part that we have to keep heavily intertwined with, and then we can start shipping off the ownership of the React library definitions to them, which will ease our burden on every time they add a new hook, they have to go through us. They have to figure out how to re-record our tests. So I think it'll be fun for everyone once we get React out of our repo and into theirs.
Cool. Maybe to that point, we could answer this audience question about how you balance adding more complex types while also maintaining ease of use for consumers.
Yeah, for us, it's really, you know, we started off this conversation talking about research, right? And in research, what do we want to do? We want to make the coolest types possible, you know, as many guardrails as possible, and, you know, just go as far as you can from it. And it was shocking to me. It really took a long time when I started on the team to flip my mind to the mindset that the TypeScript team has, which is it's all user pattern generated, right? We'll go add something to the type system, but only, or I don't know if only, that might be a bit strong, but really it has to be driven by real user patterns and real user problems. Otherwise, you're just going to get that performance hit for something maybe people use, maybe people won't, we don't know. And so I think that's really what helps us manage that, you know, on the sort of front side, making sure that we're just helping where people, the code that people already have. And then on the backside, we need to continue, maintaining those communication channels with customers, whether that's our GitHub, definitely typed, people just reaching out to us on Twitter, to really find, okay, we did this, but it's killing performance, and making sure that people can let us know.
One thing, speaking of DX, one thing I think that TypeScript did really well, maybe between 3.4 and 3.5 or 3.3 and 3.4, is adding the omit type as part of the standard library, because we anecdotally found ourselves sort of just defining that all over the place. And I know it was in the docs, you can create omit trivially from pick and exclude, but just having it built in was honestly a really nice DX improvement.
And you'll see that happen, right? That happened with omit. You'll see that happened with the unknown type, right? Where for a long time we'd say, it's just like curly, null, undefined, right? Like, go write it yourself. But it was really helpful for our users to have it built in, because it just became much clearer that way.
So this is like heavily related to the main project I'm working on right now, which is the Flow equivalent for map types. So I found that there's basically two kinds of these very special type operations. There's the destructive ones like omit, which would take an object type and remove keys from it. And then there are constructive ones. Like in Flow, we have a type level spread, which takes all the properties from one object and puts it into another. And a lot of the time, you can actually only use the constructive version of these type destructors or these type operations in order to express what you want. And I found that we've consistently found that the error messages are easier to understand when you do it in the constructive way, because usually those constructive patterns have to follow some kind of JavaScript operation that you would use to construct the type. So for things like map types, where there is no built-in JavaScript operation that expresses it, that's an instance where we could have really confusing error messages. The reason that they would probably be so confusing is because there's no function that you can write returns the map type of some polymorphic function, because that functionality doesn't exist. It's not modeling a JavaScript runtime operation. So I alluded to something like this earlier, where if we were to provide that function that does model these type destructors that don't have the runtime intuition behind them, then you can more clearly link up what the type operation is doing to your runtime code that's causing the type operation to fire, which results in better error messages.
Maybe we can take this other audience question about whether there's some early feature that you wish you could remove from TS or Flow, but can't because of the user impact.
I'll get back to you on that. I can't think of one right now, but I'm sure there's many.
So for Flow, it's a lot of these we call them type destructors in Flow, these type level operations. A lot of them were, it was like, oh, this library that we use a lot internally introduced this function and we need a way to model it. Flow, can you model it? And so we would release this dollar type. It's like dollar whatever. And really dollar meant, this is experimental, do not use it. But then dollar became the convention for, oh, this is a type level operation. And people started using dollar in their own type aliases that had type operations in them. And so now we have a huge mess of a bunch of type level operations that were like designed in a very ad hoc way, and don't mesh well together. Like TypeScript's map types are so many of our separate type destructors combined into one convenient syntax that makes sense. Whereas the way we implemented it is a bunch of ad hoc features that are really nasty to read and shouldn't have been as adopted as widely. So I would love to have never had those and gotten to design it from the ground up now, instead of thinking about how we made some code really hard to read.
Yeah, to sort of spin your question a little bit, I think one thing that we've found was originally with the language, we were a little more comfortable about driving runtime impacting features. You know, we had classes, I think, before ES6 had classes. And that became a problem with the design of JavaScript, because if we ever got in a situation where we would diverge, you know, JavaScript would win, right? Like, we're just a tool built on top. They're the source of truth. And so you may have seen this recently with our private versus private fields in JavaScript classes, where they're not the same, and that's painful for users. And so, you know, I think we've become a little more careful about what is our design space, where we're willing to go innovate, and where we want to work with the broader JavaScript community to avoid having divergence points.
Cool. I see there's still some more audience questions, and we're running out of time. This has been going really quickly, as we knew it would, because it's fun, always fun chatting with all of you. So if someone wants to know that it's very easy and quick to start writing tooling in Python due to it being weakly typed, do you have a better alternative? And how would you approach rewriting those tools, and what language would you use? So it's a few-part question. I don't know if John, that you have an opinion there.
I'm not much of a Python user, but I mean, if you wanted to introduce type safety, I believe there's something, MyPy or some sort of TypeScript or Flow equivalent for Python. I haven't used it myself, so I can't really offer an opinion though.
Yeah, I mean, I think your question touches on an important point, which is, you know, I really like TypeScript. I think it gives great structure for like really substantial code bases. But if I'm writing up a node tool that's 10 lines long, I don't need a build step. I don't want that. And so there is, you know, I'm not saying everybody needs to go switch to TypeScript as their primary way of writing JavaScript. There is a role for these tools. But as you say about Python, sometimes you just want to write up your tool in Python because it's comfortable, it's quick, you know, nobody's depending on it at scale. It's not thousands of lines long, and that's fine, because again and again, it's the developer experience. It's what's going to get your product out comfortably and enjoyably.
I think the value of the type checker really comes when your 10-line tool becomes something that you've built a product on. So yeah, I think maybe when you're first spinning up a project and iterating, to kind of echo what Ben said, you probably don't need type checking, but you know, as short-lived products often tend to become longer lived than you first expected. And I think that's where the value of incremental type checking really comes into play.
Exactly. That's where that migration story focus comes right in to help people use that pattern.
Cool. Well, it's good that you feel good about that one, Jordan, because it looks like the other remaining question is for you about how the work on Reason ML impacts flow, and maybe related. I don't know if you want to address how you sort of were talking to it a little, but this could be a good sort of point to end the hour on, about how the work on TypeScript, or maybe even the adoption of TypeScript, impacts the work on flow.
Sure. So for Reason and Flow, I think we both really want to see each other succeed. So I don't view Reason as a competitor to Flow. I view that as a different way of getting to the same place that Flow wants to get to. And that solution might be better for products that are new, have a fresh code base, don't have to interact with too much JavaScript or other languages. So I mean, Reason is I think it uses OCaml's type system, and that's the type system I use when I work on Flow. So I think I would probably really enjoy using Reason, but that might not be true for everyone. And Flow is there for those people, and for the like millions of lines that already exist, that would be hard to port. For the TypeScript side, I think the Flow team views our like target audience as like a very small subset of TypeScript's target audience, where we're really focused on the extremely large code-based use case, where it's like you know, like the code base that we are primarily checking, like our primary client, is several million lines long, and a change somewhere could require hundreds of thousands of files to be checked later down the line. And so providing a good experience for that so that you don't have to wait an hour for all these files to be checked is really where we're trying to add value. And I think we're finally at the place now where we found that we can also not have a sucky developer experience. And so TypeScript's super polished there all the time when we're chatting about like, oh, in this case, like where should getDev bring you? Should it bring you to like this reassignment, or should it bring you to the very first assignment of or like the declaration of the variable? The answer is usually, well, what does TypeScript do? Because people probably enjoy that. So we can just mimic that and probably will be fine.
Ben, it looked like you wanted to say something. No?
No, that's just fun to hear.
Okay, well, I don't know if anyone else in the audience had questions. Otherwise, maybe to close us out, you all could share how you generally pitch type systems to someone who's not familiar with it.
Yeah, I can take that. My typical approach is kind of like just emphasizing how much it lightens the cognitive load on a developer. I think some of the real value is in taking away things that you'd ordinarily need to check at runtime, especially in a dynamic language like JavaScript, and moving that to being checked at compile time. That's less things that you need to keep in your head. Also, inline documentation is a huge part. So, just by looking at something, you no longer have to rely on naming conventions or things like that that are subject to human interpretation. You have a sort of like statically defined way of like documenting what a function takes and receives. And it's very much easier to sort of reconstruct and kind of like parse a piece of code when you see type information. So I think my emphasis is really on sort of removing mental burden from the developer when I'm trying to pitch that. It's just like you're taking away the amount of things that you have to keep in your brain at once and sort of delegating that to a type checker and a compiler. And not to mention, it sort of like frees you from having to write, these tests that are performing at runtime what a type checker does at compile time anyway. I mean, assuming, your types are properly defined, you don't have to write these tests that like, assert that a number is not a string and things like that. That can be handled for you by the type checker as well.
Yeah, I mean, to build off of that, like I said in the beginning, I think the best metaphor is guardrails, right? Like you could have a windy mountain road with no guardrails, and yeah, that you shouldn't drive off the cliff. But man, it would be really nice if there was a barrier there where, it was a lot harder to drive off the cliff. And that's what the type system's doing for you.
Yeah, and like one more note on top of the like inline documentation, it's also documentation that can't go out of date, because if it does, it warns you that your code is no longer documented correctly. And that's enough for me. That's enough for me, because I always forget to update the comments on documentation.
Awesome. Thank you all for joining today. To our guests, Jordan, Ben, and John, as well as to the Techbytes committee and Kai for helping with all of that side, Larissa and the Amplifier AV team for helping with that, and of course the audience for being engaged and asking interesting questions throughout. Since generally if this had taken place in person, there would have been the opportunity to kind of socialize and talk afterwards. Maybe we can all stay on and use the chat or try to use that to sort of attempt to mimic that natural conversation that would happen afterwards. So we'll stay on the chat for a little bit to continue answering questions that people might have.
Thanks so much, Karen.
Yeah, thank
thanks,
you, Karen. So much fun. Also nice to be able to see Ben.
And thank you too, Ben and Jordan.
Yeah, it's nice being able to see you, even though we couldn't bring you to the office. So yeah, for the audience, we've been talking about doing this for a long time. So it's something I was excited to bring us all together in person, but it's nice to see all your faces virtually too.